Welcome back to 0x41414141. Today, I'm gonna show you how to solve a self-modifying Crackme using r2pipe. r2pipe is an API that allows you to easily script Radar 2 in different languages. I'm gonna use Python to solve this Crackme. Let's just run the Crackme to see what it is. Let's open it with the Radar. We can retrieve some basic information with I. Let's inspect the sections. Load 1 section is both writable and executable. Keep this in mind. Let's see if we can find some interesting string inside our binary. Here are the two strings that we already saw, and the new one, which is a good job. We can try to analyze the binary to find cross references to our string, but there are none. So let's switch to visual mode. This is the entry point of our program. It begins by moving a pointer to a string and calling a syscall, which is write, so it just prompts for password. Then it reads our password. It sleeps a moment using nanosleep. And then the stack pointer, which points to our string, is moved into RCX, and the first byte pointed by RCX is compared with the 0x78, which is the ASCII value for X. If they are equal, we move a 64-bit integer pointed by RCX into RAX. We move a size probably into EDI. We zero out ESI, and we compare ESI with EDI. So ESI is probably a counter for a loop. Indeed, we can see that if they are equal, so if we ended our loop, we jump to 0x6001b2. Otherwise, we XOR a character at the region where we will jump at the end of our loop. With RAX, and when the decryption is completed, we jump to the decrypted code. We can manually simulate the decryption using Radar. And if we now check the address where we will jump at the end of the loop, we can see that we have another loop with the same structure but different numbers. So to solve this Crackme, we just need to automate this process. I'm gonna show you three different approaches. The first one is based on emulation. We use r2pipe. We open the communication, then we set up things for emulation. So we enable cache, we enable emulation, we set the seek pointer to the first loop, the one not decrypted, and then we have a loop which basically extracts from this assembly the size of the decrypted code, the key to decrypt the code, and the address for our new value of our IP. The second version is instead based on debugging. So the approach is very similar to before at the logical level, but in this way we can't use the equivalent of a AECU, which is DCU, because since we are debugging self-modifying code, in this case the program will try to decrypt also region of memories where we put our software breakpoints, and so there will be no more breakpoints and debugging won't work. So we can avoid this, for example, using step instructions rather than continue until. And then we have the third version, which automates what we did to decrypt the second loop. So let's try to run this solution and find out which is the best one. And we have a clear winner. The third solution immediately finds the flag, while the second solution based on debugging is still working, but it's doing its job. And also the first one is working, but is very slow. I hope this video helped you to learn some new functionalities of Radari that you didn't know. And that's all for today. See you next time.